This is Lesson 6-2, Modeling Tax Schedules. The objectives of this lesson are to be able to construct income tax graphs using compound equations. There are a few key terms in this lesson. The first of these is flat tax or proportional tax. This is where the tax is a fixed tax rate. For example, our sales tax here in the state. It's the same rate regardless of how much the purchase was. The second is progressive tax system. This is where the tax rate increases as your income increases, much like the federal income tax. And in this case, you would have various tax brackets where the would be a certain percentage, and then as you move to the next bracket, it would be a higher percentage. And the last of these is a regressive tax schedule. This is where the tax rate decreases as the income increases. This is almost never used. I don't know of any examples of a regressive tax schedule. So, how can you graph tax schedules? Well, how would sales tax work if it was a progressive rather than a proportional tax? How much tax would a shopper pay if he or she needed to make a $100 purchase and the tax schedule was 6% on the first $50, 8% on any amount over $50? You can see how the amount paid in tax would be different. And lastly, describe how a progressive sales tax system is different than the current sales tax system. The current sales tax system, as I say, is the same percentage regardless of the amount purchased, whereas a progressive tax system would be a smaller amount for smaller purchases and a larger amount for larger purchases. So let's look at an example. Model the schedule shown in tax schedule notation, interval notation, and compound inequality notation. Now what you see here is Schedule Y. Y1, if filing status is married, filing jointly, or a qualifying widower. So this is what we see here in terms of the what is shown here on the example, okay? So if we were to convert this to tax schedule notation, all right? Basically what you're going to do is you're going to take this schedule form here and rewrite it somewhat mathematically but with words. For example, this first line would read over $0 but not over $18,450. Okay, so you can see it over here, over $0 but not over $18,450. If we move down, say we move down to this row right here, we would see that it says over $230,450, but not over $411,500. So these are the two amounts here, over this, but not over this, okay? Okay, now what if we were to write it as in compound inequality notation? The first row would be x is greater than 0 and x is less than or equal to 18,450. Okay, so that's what we've got here, and but not over this amount. If we move further down, let's move down to this row right here, and you can see that that's written as x is greater than $230,450 and x is less than or equal to $411,500. So this would be compound inequality notation. All right, lastly, let's look at interval notation here. All right, and let's look at this, the same row we've been using before. Over $230,450, but not over $411,500. So that would be written as 230,450 is less than X is less than or equal to 411,500. So this would be interval notation. All right, so let's look at a tax equation. So on the left side of our chart here, we have tax schedule notation, okay? Over $230,450, but not over $411,500. The tax equation would be y is equal to $51,577.50 plus 0.33 times x minus 230,450. Okay? So here's your tax equation from your tax schedule notation. Now, if we would convert this to a piecewise function, all right? You remember piecewise functions are f of x equals, and then you got this combination of different equations here depending on the value of x. And if we look here at our the one that we've been looking at here, all right, the 230,450, but not over 411,500, we would see that f of x equals $51,577.50 plus 0.33 times x minus 230,450. When x is greater than 230,450, but less than or equal to 411,500. So let's look at example 2. How does the piecewise function relate to the tax computation worksheet? All right. So here's the tax computation worksheet. It's Schedule B, all right? So let's see how this would work out. All right, so let's look at the piecewise function notation first of all. And in this case, we're going to look at this row right here. Over $150,200, but not over $230,450. And that's where we have y is equal to $29,387.50 plus 0.28 times x minus 151,200. And that would correspond to this portion of the piecewise function, okay? And this would again be for x values greater than 151,200, but less than or equal to 230,450, okay? So if I took that portion of the piecewise function, I would have y is equal to $29,387.50 plus 0.28 times x minus 151,200. All right, so let's simplify this. If I get rid of the parentheses, I end up with y is equal to $29,387.50 plus 0.28x minus 42,336. Now, if I combine like terms, I end up with y is equal to 0.28x minus $12,948.50. And as you can see, this is basically in the form y equals mx plus b. So this graph is simply a straight line with a slope of 0.28 and a y-intercept of minus $12,948.50. So now let's look at example 3. Here they want us to express the equations in the married taxpayers filing jointly schedule in y equals mx plus b form. So initially, our equations look like this over here on the left side here, all right? Now, if we were to simplify these and get rid of the parentheses, we could get it in y equals mx plus b form. So by distributing, and as I say, getting rid of the parentheses, we end up with our y equals mx plus b form for each of these equations from the tax schedule. Well, now, in example 4, they want us to examine the piecewise function composed of the first 3 equations in example 3. And these first 3 equations can be shown right here, all right? So this is for x values from 0 all the way up to 151,200. We have 3 different rates here, or brackets, if you will. So now we're going to graph the function on the appropriate interval. So we've got 3 sections here to graph. So let's see what the graph looks like. So now you can see the graph. It's basically 3 straight lines with our cutoff points being 18,450 here. So it's at a certain slope. Then the slope increases all the way up to 74,900, so it's a little bit steeper. And then it's the steepest of all the way up to 151,200. So you can see here that the tax rate or percentage increases as your income increases. There's different intervals for each of these rates, okay? So we have a slower rate here, a next higher rate, and then an even higher rate.